Hi, welcome back WeldTube family. My name is David Ciriza, and today we're going to be showing you how to weld out and pulse-weld heat treat this 8-inch flange with Superheat. You guys ready?
Yeah, let's get to it.
All right.
Hey WeldTube family, I'm Chris, I'm here from Superheat. Real excited to kick off this series with WeldTube. Today we're going to focus on what is heat treatment.
How's it going? My name is Randy. Today we're going to be doing a basic post-weld heat treatment on an 8-inch flange. One of the reasons we do post-weld heat treatment is to soften and harden the metal. It's also known as stress relieving.
All right guys, so before we do any heat treatment on this piece, we actually need a weld to heat treat. So I'm going to go ahead and show you guys how to weld this 8-inch flange out here. Now I got an 8-inch 150 flange here. We already got it all fit up. You know, I'm running a 532 gap, no land, welding this out in the 5G position. You know, I know it's on jacks, but we're not gonna roll this piece. It's gonna stay where it's at. And go ahead and start on the bottom, grind my side tack here. You know, when I grind, I wanna make sure it's a long, thin grind. That way I get a good tie-in, especially down here on the bottom. And you know, on the bottom, I'm just grinding a little bit at our start, just to be able to, you know, warm that tack up a little bit quicker. Then up here, got a long grind on it. That's gonna help me tie in, especially on the side. I know a lot of guys like to bridge tack. I like doing penetrated tacks. You know, it doesn't move as much, stays in place. I know a lot of people have trouble, especially back feeding right here on the bottom. And I'm actually going to start walking the cup right here just because it's a little bit easier for me. Just kind of break the arc, nice and soft. All right, so I'm going to go ahead and grind this other bottom quarter.
Shop welding products at weldlife.com. Durable goods that get the job done. That's weldlife.com.
All right, running the same amperage, about 93 amps. Still gonna be back feeding, 1/8 wire. Again, transitioning to walking the cup right there just to finish refilling what I ground out on the tack. Continue to work all the way through my grind and go ahead and pull out. On this quarter here, I'm actually gonna be walking the root, same thing, back feeding. So as I'm approaching my tack, I'm gonna kinda angle my torch a little more down to apply more heat to get a good tie-in. You know, these tie-ins are a little bit easier. You got gravity as your friend pushing the metal down. Go ahead and slowly break the arc. And when you're walking, just sweep. Make sure you tie into the edges. Just a nice, smooth, consistent walk. Maintaining a puddle is real crucial right here. You want your tie-in to have plenty of metal. You don't want it to be, you know, concave or suck back. All right guys, so I'm gonna go ahead and grind the root. I just like flattening it out, cleaning up any silica, leaving it nice and clean. Afterwards, give it a brush with a wire wheel. That just makes the hot pass a little bit cleaner. All right, so I'm gonna go ahead and put our hot pass in. I'm gonna be running 1/8 wire. I'll be walking the cup. I've got the machine turned up to 175 amps and just gonna be going all the way from the bottom all the way to the top. Now I do have it pretty warm, but you just gotta not stop in one place, especially on your hot pass. Same thing on this side, guys. Just walking from the bottom up. You can see, you know, this flange is a little bit in your way, especially if you're gonna walk, you might hit that flange. You may have to rotate your hand a little bit just to stay away from it. And some of you guys might be asking, why are we TIG welding this whole 8-inch? You know, a lot of companies, a lot of places choose to use TIG. It's cleaner, especially since we're gonna be doing post-weld heat treat on this joint. And I'm not saying that you can't get porosity with TIG, but the chances are a lot less when using this process. All right, so we got the machine turned up to 200 amps. You know, this is gonna be our fill pass. I'm gonna be putting a 532 on this. And again, just starting from the bottom up. The key with 532 is just maintaining a nice tight walk. You can see I'm just barely nipping the bevel edge. As hot as this fill pass is getting, the cup can become real slippery. This is just our fill pass. I'm worried about the height of the material I'm depositing. And this weld is going to be heat treated, worked, inspected. If you have to strike an arc on this after post-weld heat treat, the whole process of post-weld heat treating it and the cycle will have to be redone. All right, so I'm going to go ahead and put what I call my first cap. Now, a lot of you guys might be wondering, why do we do post-weld heat treatment like on carbon steel and stuff like that? Well, for the creators of the product, you know, like refineries, chemical plants, stuff like that, you know, that stainless and alloys ends up costing a lot more when you can actually, you know, just do a heat treatment cycle on carbon steel and get an acceptable product that'll handle what you're trying to put through it. You know, if the material's over an inch, you're gonna have to post-weld heat treat it just from the residual welding stress that's left in the joint. So a lot of times we're not really questioning the strength of the weld, we're questioning what it does to the heat affected zone, to the base material. That's what causes cracking. So the heat treatment cycle is very important for this weld here. You know, you can leave the cleanest, the prettiest looking weld, and depending on the service, it just may not be suitable for it. You know, once it's determined that it has to be post-weld heat treated, a common practice is to do a non-destructive examination before stress, which would be right after we're done welding this. They'll come inspect this weld, make sure that it's good before you actually do the whole treatment cycle. The point of post-weld heat treating is to kind of soften the heat affected zones and the weld a little bit. You know, when you're welding, you got a molten puddle and it's kind of rapidly cooling. That kind of makes the material a little harder, you know, depending on the composition of it. You know, in certain metals like chromes, stuff like that, you know, it's required to post-weld heat treat. Most of the time you'll see it done on chromes, you know, very common to see on carbon steel for caustic and various other materials, just depending on, like we said, service, thickness. You know, it can be a little awkward, a little uncomfortable at the bottom. You know, personally, I just like leaving a little taller cap, slightly. That just ensures, you know, when QCs, inspectors do their visual, you know, they don't find a low spot or something like that. And again, because it is post-weld heat treated, you don't want to have to rework it. Just want to leave a nice clean weld the first time, complete the heat treatment cycle, you'll have a good piece ready for service. When you do your cap, you just got to worry about staying consistent, just keeping it clean. Alright guys, so I got this weld all filled up, all capped out. Now we're going to hand it over to the Superheat guys, Randy and Chris, so I can show you guys what the heat treatment process looks like.
Hey guys, we're back. As you can see, David has done a great job with this 8-inch pipe, welding this flange on. We're going to take over from here. So this GR unit has a really small footprint. So if we're out in an on-site somewhere, maybe in a refinery, and space is always confined, not only do we have generation, we've got our machine as well. All right, now that we've got power running from our generator to our machine, we can connect it to our site access manager here, and it will allow Superheat's employees to have remote access to all this equipment. So we can turn stuff on, turn stuff off. Also gives our customers the ability to track the progress on all of their welds right from their phone. So they have live feed on any of the projects that we're working on.
So what we have here is our 24.1 module. So this is where the secondary power comes from the generator, and then this is what we're going to get that's going to feed the electricity to the heaters on the inside, where we're going to be actually doing the weld. Like I said before, it has 3 heaters per zone, so it would be a total of 24 heaters.
All right guys, now that we've got power coming in to our job site here, power runs to this splitter. Power goes to our smart pack here that will give us a live temperature for each one of the thermocouples that we plug into it. So our welders always know exactly how hot the weld is and the metal is at any time. The cables here will attach to these ceramic heaters, right, which will actually deliver the heat to the metal.
And then this is a thermocouple. So what we're going to do here is we're going to attach the thermocouple on 180 degrees so that it'll control each zone. What we have here is a TAU. So this is our thermocouple attaching unit. Usually just runs off 110. You always want to make sure that they're on there good so we don't have a failure. So now what we're going to do is we're going to put our heaters on, and you want to make sure that this thermocouple is in the middle of this heater. That way we're reading the proper temperature of the pipe. Now that we have our heaters on, we're going to just make sure the tails are back. That way it's not involved in anything or arcs out or gets in anybody's way. So what we have now is just a banding to make sure that it stays where it should be and doesn't move. So now that we have that secure, what we're going to do is we're going to put our insulation on to make sure that the heaters and the material are covered. So now what we're going to do is we're going to hook up our secondary cables, which is going to bring the electricity into the heater and cause it to warm up. So that's going to be controlled by our thermocouples, which is on the east and west side of this pipe. It's going to go to our smart pack.
So we've got 4 wires in here.
So what we have here is our smart pack, which allows us as an employee to unlock.
So this is another safety feature that Superheat has built into our equipment. So without a proper licensed employee who's gone through the training and been issued a smart card, without swiping the smart pack, power cannot get to the heaters. Proper steps have to be taken from turning the power on to hooking everything up to swiping the smart card before power will flow into these heaters.
So, and we always want to make sure that when we have our wrap going, that our area is secure. Like Chris was saying, once we know the area is secure and it's safe to run the process, we'll swipe our card, and it also gives us an advantage on when we're doing some bigger things, like vessels, that we can turn it on and off as we go. That way we know that there's not going to be any unwanted power coming into the system without us knowing about it. So it's a great addition.
All right, guys, we're officially flowing power to this thing. You can see our smart pack here is flashing white. It means that we're ramping up in temperature. A moment ago, we were at 111 degrees ambient. Currently, when this jumps back over to the AB circuit here, we'll show you exactly where we are. 195 degrees, all right? For today's purposes, we're gonna ramp this up to 1150 degrees. We are now in soak, which means that we're gonna hold that temperature. If this were out in the field right now, we'd hold our temperature at that target for a specified amount of time, an hour, maybe 2 hours, depends on the type of metal and the thickness. But we have achieved our target temperature.
And what we'll do is, once it reaches ambient temperature, we'll take a hardness test to make sure that everything was good and that it's in the parameters for the post-weld heat treat.
All right, guys, so there you have it. Showed you how to weld this 8-inch flange in the 5G position all the way out. And our friends here from Superheat, Randy and Chris, did the post-weld heat treatment on it.
Yep, just want to say thanks a lot for the opportunity. Thank you to the WeldTube family for having us out and letting us be a part of this. Appreciate it.
Thank you guys for an awesome job. You know, this line's already been heat treated, ready for service, ready to go. Don't forget to like, comment, and subscribe. See you guys on the next one.